BrainWave.
The Earth has not always been as we know it. It took billions of years for water and land to form on the scorching ball filled with magma. To become an inhabited world covered with mountains, forests, and oceans, it had to travel a long path. But how did our Earth come into existence? To get answers to our questions, we need to travel back in time to when the Earth itself was born. Nearly 5 billion years ago, a new star was born. This is our Sun, surrounded by stellar dust. Scientists couldn't determine Earth's age for a long time until the idea of radioisotope dating emerged in 1904. Radioactive isotopes decay at a constant rate, so we can calculate how much decay product has accumulated over the object's existence. During radioactive decay, they turn into lead isotopes. Meteorites and Earth's rocks have the same lead isotope ratios. Meteorites are remnants from the formation of the solar system. Therefore, they were formed from the same initial material and around the same time. This allowed us to link the Earth's formation to the formation of the solar system. About 4.5 billion years ago, the planets and the Sun were a cloud of gas and dust that started to condense and rotate under the influence of gravity. Atoms of hydrogen collided and heated up in the center, forming the Sun. The young star rotated quickly and dispersed the remaining gas cloud around itself. All light, volatile components like molecular hydrogen, helium, ammonia, and methane ended up in the outer cold regions. Later, these formed gas giants such as Jupiter, Saturn, Uranus, and Neptune. Closer to the Sun, larger mineral-rich particles of stellar dust remained. From them, solid planets, Mercury, Venus, Mars, and our Earth, formed. The Earth began to take the shape of a sphere, or more precisely, an ellipsoid, but it still represented a fiery ball. The temperature on Earth exceeded 1200 degrees Celsius. Only carbon dioxide and nitrogen enveloped the Earth. There was no air. The Earth consisted of liquid lava and had no solid surfaces. Molten iron and nickel sank to the center of the planet and formed the core. At the same time, another unexpected event occurred. A young planet almost as young as our Earth, named Theia, unexpectedly headed towards Earth. Traveling at a speed of about 15 km per second, the Mars-sized planet rapidly approached Earth. At that moment, Earth collided with a hypothetical Mars-sized planet called Theia. The impact destroyed Theia, and Earth absorbed most of its debris, becoming more massive. Collision debris and part of Earth's molten rock were quickly ejected into orbit. Over 10 years, this debris formed the Moon. Initially, the Moon was much closer to Earth than it is now. Due to the impact, Earth's rotation was very fast, and a day lasted only 6 hours. 3.9 billion years ago, debris from the formation of the solar system began to fall on the young Earth, bringing crystals with tiny water droplets. Over 20 million years, meteorites continuously fell on Earth, creating bodies of water and oceans. As a result of accumulating a huge amount of water and lava, the planet began to be covered by a crust, which later became known as the Earth's crust. The temperature on Earth cooled to 70 degrees Celsius, but the Earth's core remained just as hot. The water we see and use today is millions and millions of years old. Earth began to take a more familiar appearance, but everything remained dangerous, as wind speeds exceeded the speed of the most destructive modern hurricane. Due to the strong gravitational pull of the Moon, which was still close to Earth, huge waves rose, sweeping across the planet's surface. Over time, the Moon began to move away, the waves calmed, and the planet began to rotate more slowly. 700 million years after its creation, the planet was covered with an ocean, with only small islands emerging everywhere. It was then that not yet fully cooled lava burst through the water and solidified due to the enormous amount of water, forming volcanic islands that later joined to form the first continents. The emerging Earth had water and land, beginning to resemble the planet we call home. However, the atmosphere was toxic and there was intense heat. No one could survive there. Meteor showers continued from the planet's formation, bringing not only water, but also chemical elements that, when falling to the ocean floor and reacting with water and other substances, formed various chemical compounds. As a result of diverse reactions, microscopic living organisms, single-celled bacteria, appeared. Incredibly, this is how life began, marking a turning point in the planet's history. These bacteria fed through photosynthesis, with oxygen as a byproduct. Thanks to the gradual saturation of water and the atmosphere with oxygen, further life development on the planet became possible. Over the next 2 billion years, oxygen levels rose. The planet rotated more slowly, and days became longer, now lasting at least 16 hours. 1.5 billion years ago, when conditions for life were nearly created, the Earth's crust began to crack and divide into lithospheric plates due to constant volcanic eruptions. The fiery underwater plates started to crack and emerge from the water, forming new continents. Carbon dioxide emitted by the Earth mixed with water to form acid rain, which was absorbed by rocks. This is why many rocks contain carbon dioxide. In just a few thousand years, the temperature dropped to about 50 degrees Celsius below zero, and the entire planet was covered by ice up to 3 kilometers thick. The ice reflected all sunlight and heat back into space. Something had to free Earth from its icy grip. The surface froze, but the core remained as hot as the sun's surface. Volcanic eruptions continued since the world began to freeze, but even their heat and power couldn't affect the ice. Volcanoes emitted billions of tons of carbon dioxide. Before the Great Freeze, most of the carbon dioxide was absorbed by Earth's rocks. Now, surrounded by ice, nothing absorbed this gas, and it filled the atmosphere, trapping solar heat around the planet. Temperatures rose. The battle between heat and cold continued for 15 million years until the ice began to melt. Through chemical reactions between the ice and the sun, oxygen levels rose again. 600 million years ago, air temperatures became similar to ours. During this ice age, all bacteria perished, except those deep in the ocean. 540 million years ago, these bacteria began to evolve due to increased oxygen levels in the ocean, leading to the appearance of the first mollusks, which gradually grew and developed bony skeletons. Oceans flourished with thousands of diverse plants and animals, but these organisms couldn't yet live on land. The Earth remained rocky, with no signs of life due to solar radiation. Over time, another miracle occurred. Oxygen from the ocean reacted with radiation, forming a new gas, ozone, which gradually covered the planet, absorbing deadly radiation. This process took 120 million years, making the ozone layer thick enough to block radiation. 375 million years ago, the first plants appeared on Earth, releasing oxygen. In the water, one of the first fish, Tiktaalik, swam. Over 15 million years, it slowly evolved into a tetrapod, developing strong enough limbs to leave the water and become a terrestrial reptile or animal. 360 million years ago, life began to move from sea to land. But this is just the beginning of nature's emergence, and it's another story. This is our world, our time. The story doesn't end here. Much has happened, but even more will occur. Everything we saw during our journey is just half the story. We are grateful to viewers who watched this video to the end. If you want to learn more about other epochs in our planet's life, we recommend subscribing and clicking the bell icon.